Um, um, this is the index. We are going to talk first, like an introduction, what is a cell and what is the concept of cell freezing, and then we are going to talk about the current studies. Okay, first, what is a cell? The cell from Latin is cella, is the basic structural and functional and biological unit of all known living organisms. A cell is the smallest unit of life that can replicate independently, and cells are often called the building blocks of life. The study of cells is called cell biology. What is cell freezing? So it is a process called cryopreservation. The cryopreservation is a process where cells or tissues are frozen at an extremely low temperature between 80 to 196 degrees under zero to decrease the vital function of the cells or the organisms and keep them in suspense life condition for a long time. Um, this is one current study. The title is the research to freeze carcinogenic cells is progressing. Scientists at a clinic in Florida say that a molecule known as protein kinase D1 PKD1 is the key for a tumor cell to be able to remodel its structure, which allows you to migrate and invade. The researchers found out that if the PKD1 is active, tumor cells can move. During propagation, known as metastasis, invasive carcinogenic cells respond to biological signals and move growing away from other primary tumor. The PKD1 inhibits another protein known as SLING that regulates the elimination of the existing actin structures in order for new filaments to be synthesized by themselves. As conclusion, according to researchers, the PKD1 is a negative regulator of cellular migration, and if the PKD1 is not expressed in the tumor cell, the SLIM becomes active and contributes to the reorganization of actin, so that the tumor can move. And this is the bibliography where we research all that I talk about, and then thank you for coming.
Good day. My name is Jose Yangma. I am currently studying in first year of biotechnology in the Universidad Católica of Valencia, and I have prepared today a presentation explaining basic information about how to differentiate a live and dead cell using protium iodide and calcium AM. So first of all, we can distinguish between live and dead cells using fluorescent molecules. Fluorescent molecules, or also known as fluorophores, absorb the energy of light at a specific wavelength and emit energetic fluorescent light. When a fluorophore absorbs the energy of light, it becomes excited by elevating to a higher energy level. This is known as excitation. The excited fluorophores go back to the ground state by releasing the energy in form of heat and emitted light, and this is known as emission. One of the substances used to differentiate between a live or dead cell is protium iodide. Protium iodide is a fluorescent molecule that absorbs light most efficiently between 500 to 550 nanometers. It emits bright red fluorescent light at 600 to 650 nanometers wavelengths. It's hazardous, dangerous, which means you have to wear safety gloves. Since lithium iodide is available to protium iodide only enters dead cells that have porous membranes, which means that the the cells that are in red are dead cells. Once inside the cell, it intercalates between nucleic acids, both RNA and DNA. Calcium AM is a derivative of calcium. Calcium AM itself is not a fluorescent molecule. It has to enter inside the living cell, where the esterases enzymes convert calcium AM into calcium. Calcium absorbs light at 495 nanometers and emits light at 550 nanometers. Sorry, 520 nanometers. It's a bright green fluorescent compound and is permeable to both live and dead cells. Since dead cells do not have a functional trace, it only turns green live cells. As you can see in this image, the red particles represent the dead cells that are ay, que no sé la palabra. That are dyed in red using protium iodide. And the green particles represent the live cells dyed by calcium AM. So this is the bibliography, and thank you very much.
Good morning, we are Alejandro and Carmen, and we are going to talk about contamination and security in the lab. First of all, we are going to talk about what is contamination and what is security, and then some preventions. Contamination is the presence of an unwanted contaminant, constituent, or impurity in a material, physical body, natural environment, or workplace. A laboratory security system is put in place to mitigate a number of risks and is complementary to the existing laboratory security policies.
Avoidance of contamination in the laboratory requires the use of strict precautions. Among these are decontamination pipetters, wearing gloves, and choosing an appropriate pipette tip. The importance of these measures is evident when we consider the extreme sensitivity of modern techniques, such as PCR, which allows detection of a single molecule. We must also bear in mind the dangers of radioactivity and the risk of personal contamination from a pathogenic microorganism.
Contamination most frequently occurs through avoidable procedural errors. Practicing good aseptic technique is critical to maintaining the purity of cell culture and a safe lab environment.
In a general way, the preventive actions for the minimization of the risk caused by these factors are to acquire and to support good practices of work, to work with sufficient material and adapted to the needs and in good condition, to consider the safety aspects, structural of design of distribution in the phase of design, not to accumulate materials in the surfaces of work, to have the space in a rational way.
The laboratory must have the equipment of individual protection and of the emergency facilities and some elements of actions like showers, eye bath, fireproof blankets adapted to the existing risks, and a general system of ventilation. The chemical products must be manipulated carefully, not taking them in the pockets, not proving them, and not touching them without gloves, and keeping in the laboratory the minimal indispensable chemicals for daily work.
And now we are going to play a video.
Handling things like hazardous chemicals or specimens requires a great deal of caution. If we don't contain them, hazards can spread and contaminate the things around them, including you and your coworkers. Every day, we're called on to handle substances like toxins, corrosives, and carcinogens. We think we know how to protect ourselves, but are we doing all we can? Even tiny amounts of a hazardous material, combined with a few unconscious actions, can spread contamination. Let's take
And here we have a little bit glossary with some important words of our work, our bibliography.
It have had a pleasure. Thank you so much.